Okay, so in the lab, you're going to be asked to perform an unsupervised classification of this data set or image, which is a Sentinel-2 image of the area around Alexandria, Egypt, collected on August 4th, 2020. And you can see here it's displayed in like a false color composite, where you can see the differentiation of things like vegetation and developed areas and water and sand and rock. So as part of the lab, we provided a second map that is stepped through this process just using a different data set, and that's this Pittsburgh map. Okay, so we navigate to the Pittsburgh map here. You can see our full set of results there. So let's start off with the image and then talk about how we derive these results. Okay, so here's an image. Again, this is another Sentinel-2 image. This is of the Pittsburgh area collected on September 8th, 2020. So we zoom in here, you can see the city of Pittsburgh there, the point. Here's the Mon River and the Allegheny River and the start of the Ohio River. Here's the Pittsburgh Airport. So that's effectively where we're at. Okay, so again, the goal with supervised or unsupervised classification is to first cluster the data into spectrally similar categories and then assign those into informational classes. So the first step to do this in ArcGIS is to train a unsupervised classifier. So we're going to analysis here and tools, and I'm going to open up the image analyst toolbox and classification and pattern recognition. And in here, we are looking at train ISO cluster classifier. So that's an unsupervised classifier. And here you're basically going to give it the image, the number of clusters, maximum number of clusters. So here I set it to 25, and then it did some aggregation, so I ended up with 23, and then name your output. And you can fiddle around with some of the settings, but you don't have to for the lab. You can just leave the defaults. You can also add additional raster data to assist with the classification or segmented data, but we're not doing that either. So when you run that, what you end up with is this model definition file, which gets saved to disk. And then to actually apply that to the image, then you can use the classify raster tool. So here you just give it, the data you're wanting to classify, and then your model definition file, and then produce an output. And then that's what ended up producing this. So again, this algorithm defined 23 different spectral classes, but we need to turn those into informational classes. So this is where the user input comes in. Okay, so there's different ways to do this. Generally what I do is I just go through and make all of the categories transparent. Let's get it real quick. Second, that was the water one apparently. Okay, so once they're all transparent, then I just go through and turn them all on one at a time. And then I look at those pixels and get a sense of what class I want to put those into. And then I just keep a list. So this one would probably be like a herbaceous class. So I would code that into whatever code I'm using for herbaceous class. I think 13 was water, so you can see that there. There is some confusion there with shadow, it looks like, but that picked up most of the river. Okay, so anyway, that's how I do it. I just go through all of these and then map each of them to a informational class. And then once that's accomplished, then you can use the reclassify tool, and that's available under spatial analyst, and then reclassify, and you can assign those categories to numeric code. So I basically just use 1, 2, 3, and 4 for my 4 different classes. So coded those out, run it, and then I end up with this classification. So anyway, this is our output. This is my output classification. And again, the process was to generate a model, an unsupervised model file, then apply that to the raster, and then assess the image to map those into informational classes, and then use reclassify to turn that into an actual classified map.